In this topic, we looked at several types of rotary positive displacement pumps: screw pumps, gear pumps, lobe pumps, vane pumps, and tubing pumps. We saw some of the major components that make up each of these pumps, and we examined how the pumps operate. Now let's try some practice questions based on what we've covered. This is one type of screw pump called a single screw or progressive cavity pump. It contains a single screw that's located inside a casing. This end of the screw is normally connected to a driver. As the pump operates, process liquid is drawn into the pump through the suction port. As the screw rotates, cavities form between the casing and the screw. These cavities move or progress toward the discharge of the pump, carrying the process liquid along. When the liquid reaches the discharge, it's forced out of the pump. In this pump, power is transmitted from the driver screw to the idler screw through a set of timing gears. When this pump operates, there are two separate liquid flow paths inside the pump. One flow path is in the spaces between the inside gear and the crescent-shaped spacer. The second flow path is in the spaces between the outside gear, the spacer, and the casing. During operation, the lobes rotate and draw in process liquid through the suction of the pump. As the lobes unmesh, gaps are formed. Liquid is drawn into these gaps and is then trapped in the spaces between the lobes and the casing. As the lobes continue to rotate, the liquid is moved along to the discharge of the pump, where it's forced out of the pump and into the discharge piping. When the pump operates, process liquid is drawn in from the suction of the pump and trapped between the moving vanes and the casing. The liquid-filled spaces are moved along until they reach the discharge of the pump. At the discharge, the rotor is closer to the casing, so the pumping area is narrower. As a result, the vanes flex by bending over into the spaces containing the process liquid. This makes the spaces smaller and forces the liquid out of the pump. During operation, liquid is drawn into the tubing at the suction of the pump. The rollers turn with the rotor and compress the tubing, trapping liquid inside. As the rotor continues to turn, the rollers force the trapped liquid through the tubing and out the pump's discharge. Pump startups and shutdowns are an essential part of basic pump operation. The procedures that we're about to see include some of the basic steps that are often followed during the startup and shutdown of one particular type of rotary pump. But keep in mind that startup and shutdown procedures can vary according to the process, the facility, and the particular pump that's involved. So you'll always need to follow the specific procedures used by your company. We'll use this single screw pump for our discussion. It's used in a process to transfer fuel oil from storage tanks to a boiler. The pump is driven by an electric motor. A series of valves is used to direct the flow of oil to and from the pump. The first step in the startup procedure is to line up a liquid supply to the suction of the pump. The operator does this by opening the valve in the suction line to the pump. The next step is to line up the discharge side of the pump. The operator does this by opening the valve in the discharge line from the pump. After lining up the pump, the operator visually inspects it for any obvious signs of problems. When he's satisfied that the pump is ready for operation, he goes to the control panel and pushes the start button. Once the pump is operating, the operator will stay alert for symptoms of trouble, such as leaks, unusual sounds, and excessive vibration or heat. He'll also check the pump's discharge pressure to make sure that it's normal. If he notices any problems, he'll report them to supervisory personnel immediately. When the pump is no longer needed, the operator receives permission and shuts off the pump. Then the operator closes the discharge valve at the pump and closes the pump's suction valve. Like all positive displacement pumps, a rotary pump will deliver a controlled amount of liquid to its discharge during normal operation. But if the discharge is blocked, the liquid won't have any place to go. If this happens, pressure could build up and damage or destroy the driver, the pump, or other equipment. To prevent this, most positive displacement pumps, like this one, have some type of protective device to guard against excessive pressure. A common protective device used for this is a relief valve. Relief valves are normally found in one of two locations: at the discharge of the pump, or on the discharge piping. But regardless of where a relief valve is located, it's activated when the discharge pressure of the pump exceeds a predetermined value, or set point. On this rotary pump, the relief valve is installed here. Inside the valve body is a valve disc, a valve seat, and a spring. The inlet to the relief valve is connected to the discharge of the pump, and the outlet of the valve is connected to the pump suction. During normal pump operation, the spring holds the disc closed on its seat. If the discharge pressure becomes excessive, it overcomes the spring. This moves the valve disc off its seat. When this happens, the process liquid flows back to the suction side of the pump and recirculates through the pump. This relieves the pressure from the pump's discharge. When the discharge pressure falls and is no longer excessive, the spring overcomes the pressure that's holding the valve disc off the seat and reseats the valve. In this topic, we looked at some basic procedures used to start up and shut down one type of rotary pump. We also saw how a relief valve works to protect a pump and its associated equipment from excessive pressure. Now let's try some practice questions. The first step in the startup procedure is to line up a liquid supply to the suction of the pump. The operator does this by opening the valve in the suction line to the pump. The next step is to line up the discharge side of the pump. The operator does this by opening the valve in the discharge line from the pump. During normal pump operation, the spring holds the disc closed on its seat. Select the arrow to the discharge of the screw pump. Select the normal direction of flow on this screw pump. Select the arrow to the area of this screw pump where the liquid is first trapped for movement through the pump. If the gears on this external gear pump turn in the direction shown, where is the suction side of the pump? Select the arrow to the suction of this screw pump. Select the arrow to the area of this screw pump where the liquid is first trapped for movement through the pump. Select the arrow to the area of this screw pump where the liquid is forced out of the pump. The gears in this external gear pump turn in the direction shown. Select the arrow to the discharge side of the pump.